Hello, Jonathan Wagner here from solidzymes.com, and this week I'm going to show you how to immobilize an enzyme and compare the activity and stability of that enzyme back to the soluble form. So I have here a small sample of a commercial enzyme carrier. This is a material that has large pores and amines on the surface, so the enzyme can come in and interact with the surface through ionic interactions. And I have some 50 millimolar phosphate buffer pH 7. And I'm going to equilibrate the pH of the carrier before I add the enzyme. So I'm just going to add buffer to my tube until it comes up to the 1.5 mil mark. Okay, so that's 1.5 mils plus the carrier in the tube. And I'm just going to put it on this carousel to rotate. I'm going to let it rotate for about 2 hours, and then I'm going to add fresh buffer on top of the sample and then let it mix again overnight. Tomorrow morning we'll check the pH and make sure that it is in fact pH 7, and then we'll be ready to add the enzyme. So I'll see you then. Okay, so I've got my samples off of the carousel. They equilibrated overnight with the buffer. I exchanged the buffer once for a fresh buffer, and I have a small pH probe that I put in them this morning and confirmed that the pH of the buffer had equilibrated to about plus or minus 0.2 pH units of the original pH, the pH that I want. So the carrier has been equilibrated, and now I'm going to take 3 of my 6 samples and I'm going to activate the surface with glutaraldehyde. So I have here 1% solution of glutaraldehyde in water. I've already taken the buffer off of my samples as much as I possibly could. So I'm just going to add 1 ml of this glutaraldehyde to 3 of my samples. Being careful not to get it on my skin. Okay, so I'm going to let that mix for about half an hour, and then we'll come back, wash them off, and add the lactase enzyme. Okay, I finished washing off the glutaraldehyde from my samples, and I have a solution of lactase enzyme. I know what the concentration is. I've also already dried one of my samples of carrier, and I weighed it before and after, so I know that it was holding 200 microliters of liquid because it lost 0.2 grams as it dried. And I know that I want to bring my final immobilization volume up to 500 microliters. So I'm going to add, so onto the 200 microliters that's already in the carrier, I'm going to add 87 microliters of the protein solution, which has my milligram of lactase, and then I'm going to add 213 microliters of 50 millimolar phosphate in order to make 500 microliters total. All right, so let's go ahead and do that. 87 microliters of enzyme. And 213 microliters of immobilization buffer. It's just enough to mix in the carousel. So I'm going to put that here. I'm going to do the rest of the samples the same way. Oh, actually I'm going to take a few microliters of this in order to measure the absorbance of this sample at 280 nanometers, because I need to know what the protein concentration is. And importantly, I'm letting it mix a little bit with the carrier because the liquid from the carrier is going to come out and dilute my protein. But I don't want to wait too long because protein is already starting to immobilize. So probably within a minute or so, I'm going to get just a few microliters for the nanodrop spectrophotometer later. And that will help us know how much protein is mobilizing, because we're going to measure it before and after the immobilization reaction. Okay, so these are going to go in the carousel and they're going to mix overnight. It really only takes about 6 or 7 hours for the reaction, but in this case the day is winding down, so we're going to go overnight. So I'll see you tomorrow to unload the protein samples. Okay, so I've taken my samples out of the carousel after their overnight immobilization, and I took a few microliters to our nanodrop spectrophotometer and measured the absorbance at 280 nanometers. So I know that about 90% of the protein bound to the carrier overnight, about 10% is left in solution. And so now the job is to wash off that remaining 10% so it doesn't interfere with our activity assay. And to do that, I'm going to use a 200 microliter pipette tip to go all the way to the bottom of the sample, drain off the protein by withdrawing from the bottom, making sure that I don't bring up any of the carrier on the outside of my pipette tip. Then I'm going to add 1 ml of buffer to the sample, invert it, give it a few minutes to settle, and then I'm going to withdraw it again. I'm going to use the 1 ml tip to withdraw from the most of it, and then I'll use the 200 microliter tip to go into the sample again, so I don't get any beads in my pipette when I'm withdrawing the solution. I don't want to get any of my carrier because that would reduce the activity in my results. Okay, so that was one wash. I'm going to do it 4 more times for this sample, and then 5 times for my other 5 samples, and then we'll be good to go. Okay, so today is activity day. I'm going to be measuring the activity of my immobilized and soluble samples over time today and keeping them at 60 degrees Celsius in between times. Now, I've already done a scouting experiment yesterday where I took some soluble lactase and I kept it at 60 degrees and measured the activity after 6 hours. So I already know that most of the activity will be gone after 6 hours. And that's important because I know this is going to be a one-day experiment. I started early in the morning so I can get as many time points as possible before the evening. And I'm just going to take you around and show you my setup really quick. So over here is an incubator mixer where I've got the immobilized samples in. They're set to 60 degrees. Here is the water bath where I have tubes of buffer and where I'm keeping my soluble enzyme aliquots at 60 degrees. And I'm going to use those to wash the samples. In between every reaction, I'm going to wash my immobilized samples 5 times with hot reaction buffer to wash off the glucose products and get ready for the next reaction. Now I'm measuring the rate of this reaction by measuring the glucose concentration. You can see I have a plate reader and glucose standards and samples from my reactions that have reacted with this StanBio liquid color glucose detection solution. So I'm going to keep on measuring the activity during the day of the soluble and immobilized samples in parallel, and then when we're done, we're going to make a graph and see how we did. Okay, I finished measuring the activity over the course of 10 hours with all my enzymes at 60 degrees Celsius, and I put the results in Excel and calculated the specific activity at each time point. Before we jump into that, I want to talk a little bit about how I calculated specific activity. It's a little bit different for soluble and immobilized samples. Specific activity is always micromoles per minute per milligram. And for the soluble sample, you can get the micromoles by multiplying the concentration of glucose, that's the product I was measuring, in millimolar times the number of mils in your reaction volume. Okay? And if it's an immobilized sample, it's the same calculation. However, you need to include the number of mils that is in the beads when you add the reaction buffer and the substrate. So in my case, I had about 200 microliters in the beads, and so I added 200 microliters less to the immobilized samples in order to get the same reaction volume. The reaction time is straightforward. We just measure the time, and we do both types of samples in parallel. The enzyme concentration, for the soluble samples, I took an aliquot out of the 60°C water bath. I added a volume that gave me 1 milligram. Okay, so the calculation is the mg per mil concentration of my sample times the number of mils which I add to the reaction. But for the immobilized enzymes, I'm just reusing the same immobilized 1 milligram of enzymes. And it's not exactly 1 milligram because when I immobilize them, not all of the enzymes bound, about 90% of them bound. So the number of milligrams is calculated by measuring the milligrams when I begin the enzyme immobilization reaction minus the milligrams that were left over when the immobilization ended. So I was using about 0.9 milligrams for my immobilized enzymes and 1 for the soluble enzymes. Okay, so we measured the activity for both these samples over time and graphed the results. And what we found was the soluble enzymes started off much more active, about twice as active. They lost their activity very quickly at 60 degrees C, and after only 1 hour they were close to the level of activity of the immobilized enzymes. However, after that first hour, like everything kind of leveled off. And so especially the covalently immobilized lactase had a similar stability as the soluble lactase. So in the end, when we added up the yields, the soluble enzyme had the highest yield. The ionic and covalently immobilized enzymes both had about 70% of the yield. However, I would prefer the covalent immobilization in this case because it's much more stable, and it looks like it might have actually lasted a little while longer compared to the ionic immobilized enzyme. Now, if the only thing we're interested in is getting as much lactose broken down as possible, then the soluble enzyme is the winner here. But I will say that This enzyme wasn't actually soluble at 60 degrees C. It formed a milky white precipitate, whereas the immobilized samples were clear. So if cleanliness is an issue and you want to keep precipitated enzymes out of your product, that might be a reason to use the immobilized samples. Um, but another thing that we could do is try to improve the immobilization, either by changing the conditions that we immobilized enzymes under, or getting a new material to immobilize our lactase on, and try to improve the activity of our immobilized enzyme. I think it should be possible, especially to improve that one time point at the beginning. This is something that we specialize in here at Solidzymes. So if you're interested in optimizing immobilized enzymes, please look us up. Check out some of our services. You can find us at solidzymes.com. Or if you just want to talk to me and get some advice about your immobilization project, you can always email me, jonathan@solidzymes.com. I hope you enjoyed this video, and thanks for watching. I'll see you next time.